Water is used in virtually all manufacturing processes. 3. It is required in photosynthesis for the manufacture of plant food. 4. Distilled water is used in the manufacturing of drugs. 5. They are used in chemical industries and cleaning parts of machines. Then how can water be tested for? Because it's very, very important also, because UTMA try to stretch you sometimes beyond your bound. That is why it is good to fire all cylinders so that any dimension the question is set, you'll be able to attend the question, and not only attend, but get it right. Now, test for water. When a few drops of water are added to we can only test for water by using anhydrous copper 2 tetrasulfate 6 and also cobalt 2 chloride. In the case of copper 2 tetrasulfate 6, it is white. Anhydrous form is white of that, and when it now combines with water, it forms a what? A blue hydrated. So that can be shown on the board. When a few drops of water are added to white anhydrous copper 2 tetrasulfate 6, it turns blue, and this is what you have. This is an anhydrous form of it, which is white in nature. As soon as the water is introduced, then you have the formation of what? Blue hydrated, which is known as what? Copper 2 tetrasulfate 6 pentahydrate, because of what? 5 molecules of water. Then also the blue cobalt 2 chloride. When you introduce water into that, you have the blue anhydrous, this cobalt 2 chloride. Then when you have introduction of 6 molecules of water, then you have the formation of what? Pink hydrated, so which is cobalt 2 chloride hexahydrate. So that's what you have. So that is how to test for water. You can either use anhydrous copper 2 tetrasulfate 6 or use cobalt 2 chloride. Then let's see questions designed for this particular topic. The first question says that a sample of hard water contains some calcium sulfate. Look at that. It contains what? Some calcium sulfate. And calcium sulfate is for what? It's for permanent hardness. Take note of that. And also calcium hydrogen trioctocarbonate 4. This one. It contains this and this. The question now says the total hardness may therefore be removed by A. Boiling the water. Boiling will remove this, but will never remove this. So A can never be the option. Option B, adding excess calcium hydroxide. If you have excess calcium hydroxide, how can you remove permanent hardness? Permanent hardness can be removed either by using what? Sodium hydroxide or sodium trioctocarbonate 4. So also that cannot be suitable. That can only remove the temporary hardness as a result of what? Calcium hydrogen trioctocarbonate 4. So option B is not also suitable. Option C, adding sodium carbonate. Yes, by adding sodium carbonate you will remove hardness. And once permanent hardness is removed, automatically that can also remove what? Temporary hardness. Then adding magnesium hydroxide. If you add magnesium hydroxide, it's also the same thing as adding calcium hydroxide, because both calcium and magnesium, they are good two elements, so they will also perform the same purpose. So in that situation, the most suitable option in this regard will definitely be option C, which is addition of sodium carbonate. That is C. So number 1 is option C. Then question 2, which of these gases may not be dried with concentrated sulfuric acid? Concentrated sulfuric acid will definitely dry HCl. That is suitable for HCl, hydrogen chloride. It cannot dry ammonia. It can dry chlorine. It can dry sulfur oxide and HCl. So the only one that it will not dry is ammonia, because the drying agent that is suitable for ammonia is our quicklime. That's calcium oxide. So it is ammonia that drying agent will fail to dry. Then the next question, question 3, which of the following compounds will form a solution if exposed to the atmosphere? A compound that will form a solution when exposed to the atmosphere will definitely undergo what? A fluorescence. And what are those major fluorescent compounds or substances that we have? I said washing soda is one. I also said global salt is the second one. So this is global. So let's check out for these two substances in the option and see whether they will be available. One of them must be available. Option A, the first one is Na2CO3.10H2. You can see that it's there. Option B, NaNO3. That one is a hygroscopic substance, so that is nullified. Option C, copper sulfate. Copper sulfate is never a drying agent. D, calcium chloride. Calcium chloride is also a drying agent, but it is a deliquescent substance. Take note. So the only option that will be suitable in this regard will be option A, which justify what? Washing soda. Then question 4. A salt that loses moisture on exposure to the atmosphere is said to have undergone efflorescence, because efflorescence is a phenomenon whereby salt, when exposed to the atmosphere, loses water of crystallization, and that is what the question is justifying, that a salt that loses what? Moisture or water of crystallization. That would definitely be what? Efflorescence. So option A, effervescence. Effervescence is never an option, because effervescence is a process that involves what? Boiling. So there is boiling and a particular gas will what? Escape in the process. So that is not suitable here. Option B, hygroscopic. It can never be hygroscopic simply because a hygroscopic substance absorbs moisture and does not turn into solution. But this one they are talking about the one that will lose water of crystallization. So that is why option B can never be suitable. Then option C, deliquescent. Deliquescent is also using the concept of hygroscopic, but the major difference is that in the case of deliquescent, having absorbed moisture, it will eventually turn into solution. So then option D, a salt that loses moisture on exposure to the atmosphere is said to be, so definitely this option D is efflorescent, and that is the correct option. That's option D is the correct option. Number 5, which of the following is a hygroscopic substance? One thing you must know about hygroscopic substance is that it absorbs moisture and does not turn into solution. So I gave you the examples of those species that, or those substances that undergo hygroscopy, and they are what? Calcium oxide, copper oxide, and sodium triazonitrate 5. Option A, NaNO3, that's sodium triazonitrate 5. B, magnesium chloride, no. C, F is Cl3, no. D, calcium chloride, no. Calcium chloride is deliquescent. Iron 3 chloride is also deliquescent. Magnesium chloride is never a drying agent. So the option A is the correct option here, which is NaNO3. That is sodium triazonitrate 5. Question 6. Which of the following drying agent is not suitable for drying hydrogen sulfide? A, calcium oxide. It's not suitable. Calcium oxide will dry because it will dry all gases. That's P2O5. So it's not suitable. That's what the question says. It's not suitable for drying hydrogen sulfide. Calcium oxide will dry hydrogen sulfide. B for O10, that is phosphorus 5 oxide. That one will also dry hydrogen sulfide. C, calcium chloride. Calcium chloride will also dry hydrogen sulfide. Then D, H2SO4. H2SO4 is not going to dry hydrogen sulfide simply because there will be a reaction. It will react with it. Instead of drying it, it will react with it to form another compound. So the correct option in question 6 will definitely be option D. That is H2SO4. That's tetraoxophate 6 acid. That is the only one that is odd in this regard. Question 7. Water will definitely be said to be temporary when it contains calcium, hydrogen, triazocarbonate 4, and magnesium, hydrogen, triazocarbonate 4. Take note of that fact. So let's see our option and see the one that will definitely be suitable. Option A, calcium, hydrogen, triazocarbonate 4, yes, and calcium, triazocarbonate 4, no. Although yes, that calcium tetracarbonate 4 can also be, but it's not, because we have to pick the most appropriate here. Then B, magnesium hydrogen tetracarbonate 4, yes, and calcium sulfate. No, calcium sulfate is a permanent permanent hardness in water. So automatically option B is nullified. Option C, calcium sulfate is nullified without even looking at the second compound. D, calcium hydrogen tetracarbonate 4 and magnesium hydrogen tetracarbonate 4. That would definitely be, because this is the answer, and that is option what? Option D. Next question. Steam changes the color of anhydrous cobalt 2 chloride from this one. We just did this not quite long, and I said that for cobalt, to test for this one is testing for water, and if you have to test for water, we use anhydrous copper 2 tetrasulfate 6, which is white in color, or we use cobalt chloride. What happens is that in the case of anhydrous copper 2 tetrasulfate 6, the white color becomes what? Blue, once water is introduced.